Good morning, everyone. Today we will learn a new subject in our current fourth semester. And the subject code is 18M404C, and the subject name is Fluid Mechanics and Hydraulic Machinery. And the very first chapter belongs to this subject is Properties of Fluids. Right? So, our subject name is Fluid Mechanics and Hydraulic Machinery. What exactly fluid mechanics? And what exactly hydraulic machinery? Why we have to study this subject? What is the importance of the subject? What is the significance of the subject? Why we have to study? All these things we will come to know now, right? So before going into the subject, fluid mechanics and hydraulic machinery, what is the importance? Being a diploma student, why we have to study this subject? What is the main importance? The main importance of this subject is generally fluid mechanics is nothing but it is concerned with the behavior of the liquids and gases which are at rest as well as in motion. This is related to fluid mechanics. And related to hydraulic machinery is nothing but the machines which we are going to deal with the fluids. Nothing but in different kinds of devices are there. For example, pumps and turbines. In that, the basic medium which we are using is fluid, nothing but hydraulics. So that is another part, hydraulic machinery. And first we will study related to fluid mechanics. Right? So just now I said fluid mechanics is nothing but it is mainly concerned with the behavior of the liquids and gases at rest and as well as in motion. Now, what is the significance of the subject? Why we have to study this subject? Only for mechanical engineering only we have to study this subject? No. Generally the subject is open to wide area. Wide area in sense, being a mechanical engineer, we have to study the subject, and coming to the civil engineers, they have to study the subject, and whereas coming into the chemical, they have to study the subject. What is the importance? Now we will see, right? So as a mechanical engineering, why we have to study this subject means, because generally we will deal with various types of devices like pumps and turbines, right? So in that we have to study the properties of fluids, how the pressure and velocity, how it is varying, right? So for that purpose mainly we have to study this subject, right? So being a mechanical engineering, why we have to study means we have to get a required knowledge of fluid properties to design pumps, turbines or rockets, etc. Right? So whereas coming up to the civil engineers, they require thorough knowledge to study the river currents and erosion or else in irrigation channels, right? So they have to have a thorough knowledge in this field, right? So whereas in case of chemical processing, in case of chemical processing of plants, they require a thorough knowledge of fluid mechanics, right? So always they will deal with fluid. Fluid is nothing but here liquids or gases, right? So they have to get a thorough knowledge about this, right? So apart from this, another branches also there. For example, biomechanics. In biomechanics, the flow of blood is of main interest, right? How much pressure the blood is circulating to all the parts, right? So this is the main significance of the subject, right? So being a mechanical engineering, why we have to study means we have to get a thorough knowledge on the properties of the fluid in order to design the devices such as pumps and turbines, right? So for this purpose we have to study this subject, right? Now, what are the main objectives? Main objectives means we have to, on completion of this period or upon the end of this session, we will have a thorough knowledge on what is fluid, nothing but define fluid mechanics and properties of fluids, right? So we have to get a thorough knowledge on what is fluid mechanics and what are the properties of fluids, right? Now, these are the main objectives. Right, so on completion of this period, we will study these topics, right? So first, fluid mechanics. What exactly fluid mechanics? Fluid mechanics is nothing but it is that branch of science which deals with the behavior of the fluids. So the branch of science which deals with the behavior of the fluids at rest, position and as well as in motion, right? So mainly the fluid mechanics is related to, we have to study the behavior of the fluids when it is in rest position and as well as when it is in motion, right? So this branch of science mainly deals with statics, kinematics and dynamics of the fluid. The main it will deals with statics, nothing but fluid statics, fluid kinematics and as well as fluid dynamics, right? So fluid mechanics nothing but it is that branch of science which deals with the behavior of the fluids. Here fluids are nothing but liquids and as well as gases, right? So fluids are nothing but liquids and as well as gases which are at rest position. We will study the liquids and gases which are in rest position and as well as which is in motion, right? Now we will see what is fluid statics. Fluid statics. Fluid statics is nothing but the study of fluids which are at rest position is nothing but fluid statics. The study of fluids which are in rest position is nothing but fluid statics, right? Fluid kinematics. What is fluid kinematics? It is nothing but the study of fluids in motion. The study of fluids in motion where the pressure forces are not considered, right? So the pressure forces are not considered is called fluid kinematics. Then what we will consider, right? So mainly we will deal with pressure, but in this fluid kinematics we are not going to consider the pressure forces. What we are going to consider? We have to consider the velocity and acceleration of the fluid. We have to consider the velocity and acceleration of the fluid particles, right? So that is nothing but fluid kinematics. And next one is fluid dynamics. What is fluid dynamics? Fluid dynamics is nothing but the study of fluids. The study of fluids in motion. Study of fluids in motion where pressure forces are also considered for the fluids in motion. Earlier in fluid kinematics, we are not going to consider the forces which are acting on the fluid particles, but it is in motion. Whereas in fluid dynamics, the fluid will be in motion and at the same time, we have to consider the pressure forces, right? We have to consider the pressure forces, right? So that is something but fluid dynamics, right? So fluid dynamics again, it is a very vast subject, right? So we will not deal with the mainly dynamics, right? Now next one, definition of a fluid. What is fluid? Right? So we have learned what is fluid mechanics, right? Nothing but branch of science which deals with the behavior of the fluids at rest and as well as in motion. Right? Now what exactly fluid? What exactly fluid means? Any substance which is capable of flow is known as fluid. Any substance, if you take any kind of substance, whether it is capable of flow, it is nothing but a fluid, right? Examples: air, water, or any kind of syrups or any kind of gases, right? So any substance if you take which is capable of flow, the substance which is capable of flow is known as fluid, right? Or else another definition is also there for fluid. It is nothing but the substance which deforms continuously. The substance which deforms continuously under the action of shear force. Under the action of shear force, regardless of its magnitude. Regardless of its magnitude. Nothing but if you take a fluid, right, it will goes on deformation continuously. It will goes on deforms continuously under the action of shear force, right? How much small amount of the force it may be, it will goes on deforms continuously, regardless of its magnitude. Nothing but direction, right? So there are two definitions of the fluid. A simple definition is nothing but any substance which is capable of flow is nothing but a fluid, right? Now, matter. Generally, matter we studied this matter in 10th class in our at school level also, right? The matter mainly it is classified into three types. They are solids, liquids, and gases. Matter is mainly classified into three types. They are solid, liquids, and gases. These liquids and gases are nothing but fluids, right? So earlier we have seen liquids and gases, these both are nothing but fluids, right? So just now we have seen the definition of the fluid. It is a substance which is capable of flowing under the action of shear stress, right? However small it may be. Now, what is the main difference between these solids and fluids? How solids and fluids are differentiated? right? How it is categorized? How it is categorized means solid. Generally, we will know the solid have a definite shape, and it will having a fixed volume. Solid is having a definite shape and it consists of a fixed volume under the given conditions, right? So solid is having a fixed volume and having a fixed shape under the given conditions, right? The solids, these resist shear or deforming forces. Solid resists shear or deforming forces, right? So fluids have no particular shape, right? If you take a water, or else if you take liquids, or if you take gases, this doesn't have any particular shape, right? So fluids have no particular shape and they deform continuously under the action of shear force, right? How much small amount of the force if you apply, they will goes on deform continuously, right? Whereas solid resists the forces, right? So whereas the solid resists the shear force or deforming force, whereas the fluid doesn't resist the shear forces, it will goes on deforms continuously, right? So further, these fluids are classified into two, right? So they are liquids and gases. What is the difference between liquids and gases? Liquids and gases, the main difference between these two is liquid having a fixed volume. Liquid having a fixed volume and it will take the shape of the container. Whatever the shape of the container is there, the liquid will take that shape, right? So a liquid has fixed volume and forms an interactive with or an interface with the surrounding, right? Interface with surrounding. Whereas gases will occupy the entire container. Gases will occupy the entire container and it doesn't have any fixed volume. It fills up the whole volume of the vessel containing. It fills the whole volume of the vessel containing, right? So this is the main difference between solids, liquids and gases, right? So another differences between the solids, liquids and gases means depends upon the molecular forces. Molecular forces or intermolecular force of attraction, right? Nothing but spacing of molecules, right? Nothing but in case of solids, if we take solids, the spacing between the molecules are very small. The spacing between the molecules are very small. Whereas in case of liquids, the spacing between the molecules are somewhat far as compared to that of solid. Whereas in case of gases, the spacing between the molecules are very far. The spacing between the molecules are very far, right? So in solids, the spacing between the molecules is very small and intermolecular force of attraction is very high. The force of attraction is very high, right? Now we will see this particular figure 1, fluid under the action of shear force, right? Now in the first figure, when the fluid is at initial state, right? Fluid is at initial state, nothing but at a rest position, right? So when the fluid is at rest position, it will be still, nothing but it will stay wherever it is. The fluid particles will be at rest, right? Now under the action of shear force, for the same fluid when it is in rest position, if you apply a small amount of force, what will happen? It will tends to deform continuously. So for example, if you take this particular figure, now 0 1 is at rest position. If you apply a little amount of force, the fluid will tend to deform continuously, right? Now the fluid particles which is at 1 is shifted to 1 dash. The fluid particles which is at 0 1, it is shifted to 0 1 dash, and again it is further shifted to 0 1 double dash, right? So it goes on deforms continuously, whatever if you apply little amount of force, right? Now types of fluids. Now we have seen what is fluid mechanics. Now what are the different types of fluids, right? So fluid is nothing but any substance which is capable of flow is nothing but fluid, right? Types of fluids. What are the different types of fluids? The different types of fluids, mainly fluids are classified into 5 types. They are ideal fluid, real fluid, Newtonian fluid, non-Newtonian fluids and ideal plastic fluids, right? So fluids are classified into mainly 5 types. They are ideal fluids, real fluids, Newtonian fluids, non-Newtonian fluids and ideal plastic fluids, right? So what are these 5 types? We will discuss now, right? The first one, types of fluids. And that ideal fluid. What is ideal? Ideal fluids. Fluid is nothing but substance which is capable of flow. It is nothing but fluid. What is ideal fluid? Ideal fluid is nothing but the fluid which is incompressible. The fluid which is incompressible and has no viscosity. The fluid which is incompressible in nature and doesn't have any kind of viscosity is known as the ideal fluid. What is incompressible and what is viscosity? Incompressible is nothing but it is one of the fluid property. So what exactly incompressible means? The density of the particle, the density of the fluid will be remains constant. The density of the fluid will be remains constant. No viscosity. Viscosity is nothing but it is in general nothing but related to the thickness of the fluid, right? So viscous, but nothing but it is doesn't have any kind of viscosity. For ideal fluids, it is incompressible in nature and having no viscosity. But the ideal fluid has no viscosity. Since the ideal fluid has no viscosity, there won't be any effect of temperature on it. Since it is ideal, so that means there is no effect of any temperature on an ideal fluid. However, the ideal fluids are only an imaginary fluid. The ideal fluid is only an imaginary fluid. Imaginary fluid means we have to imagine, right? So because generally if you take any kind of fluid, it will have some extent of viscosity. Whereas we are considering that for this particular type of ideal fluid, it doesn't have any viscosity. But if we take any kind of fluids which are in practice or which are existent, it will have a minimum to maximum, it will have a viscosity. But for ideal fluid, there is no viscosity, right? So that is ideal fluids. Next one is real fluids. What is real fluids? The fluids which has certain value of the viscosity is called as a real fluid, right? So just now I told any kind of fluids which are existing in nature having certain viscosity, it may be small or it may be high, right? But it doesn't have a zero. For ideal fluids, we are assuming that the viscosity of that particular fluid is zero, right? But whereas for real fluids, the viscosity, it will have certain viscosity, whether it may be small or whether it may be big, right? So in practice, all the fluids are real fluids. Why? Because all of them having viscosity, whether it may be small or high, right? For real fluids which are liquids, the viscosity reduces as the temperature increases, right? So generally for real fluids, as the temperature increases, the viscosity will be reduced, right? And for the real fluids which are gases, if we take gases, the viscosity increases as the temperature increases, right? The viscosity increases as the temperature increases. For example, if we take grease, the substance grease, right? So we know that initially the grease is very thick in nature, it is very thicky in nature, it will have more amount of viscosity, right? At room temperature, it is the property of the grease is having very thicky and it will have more amount of viscosity. Now if you start heating the grease, what will happen? From the room temperature to certain temperature, what will happen? As the temperature increases, the viscosity of the grease will be goes on reducing, because the intermolecular force of attraction between the particles will be far, right? So that's why for the liquids, the viscosity will be reduces as and when the temperature increases, right? So whereas if we consider for gases, initially the spacing between the molecules in the gases are very far. If it goes on starts heating, what will happen? The spacing between the molecules will come very closer. That means the viscosity of the gases will be increases when the temperature increases, whereas it is vice versa in case of liquids. As the temperature increases, the viscosity of the liquids will be tends to decreases, right? That means viscosity, the effect, the temperature effect will be there on viscosity, right? So there will be effect on effect of temperature on viscosity, right? Now next one is Newtonian fluid. Third one is Newtonian fluid. What is Newtonian fluid? Newtonian fluid is nothing but the real fluids which obeys Newton's law of viscosity is called as Newtonian fluid, right? The fluids which obeys the Newton's law of viscosity is known as Newtonian fluid, right? So as per the Newton's law of viscosity, the shear stresses between various layers of the fluid is directly proportional to the rate of shear strain or the velocity gradient, right? Simple, nothing but Newtonian fluid in which the real fluid which has to be compulsory obeys the Newton's law of viscosity, which has to be obeys the Newton's law of viscosity, right? So as per the Newton's law of viscosity, the shear stress is directly proportional to the rate of shear strain or else directly proportional to the velocity gradient. Velocity gradient is nothing but the velocity, the rate of change of velocity over a length. The rate of change of velocity over a length is nothing but velocity gradient, right? Now next one, fourth one is non-Newtonian fluids. Non-Newtonian fluids are nothing but simple. In case of Newtonian fluids, it will obey the Newton's law of viscosity, whereas in case of non-Newtonian fluid which will not obey the Newton's law of viscosity is nothing but non-Newtonian fluid, right? So in this particular type of non-Newtonian fluids, the rate of shear stress between the various layers, is not directly proportional to the rate of shear strain, which is not directly proportional to the rate of shear strain or velocity gradient. It is nothing but non-Newtonian fluids, right? Whereas ideal plastic fluid. What is ideal plastic fluid? The fluid in which the shear stress is more than the yield value, right? Shear stress is more than the yield value and it is proportional to the rate of shear strain or velocity gradient. Then after it is proportional to the rate of shear strain or velocity gradient. It is nothing but ideal plastic fluid, right? So ideal plastic fluid is nothing but the fluid in which the shear stress, the value of the shear stress is more than the yield value, and then after the shear stress is directly proportional to the rate of shear strain or else velocity gradient, right? So these are the 5 types of fluids. What are the 5 types of fluids, right? So first one is ideal fluid, second one is real fluid, third one is Newtonian fluid, fourth one is non-Newtonian fluid, and fifth one is ideal plastic fluid. So in simple, ideal fluids are nothing but the fluids which are incompressible in nature and having no viscosity is known as ideal fluid, right? Whereas ideal fluids are imaginary fluids, no real fluid. What is real fluid? Real fluids are which are existing in nature. The fluids which are existing in nature is known as real fluids, right? So whereas for real fluids, it will have a certain viscosity. Right? And that viscosity will affect, it is affecting on temperature, right? So viscosity will have effect on temperature, right? Next one is Newtonian fluid. Newtonian fluid is nothing but the fluid which is the shear stress, the fluid which obeys the Newton's law of viscosity. The fluid which obeys the Newton's law of viscosity is known as Newtonian fluid, right? Whereas in case of non-Newtonian fluid, the fluid which does not obey the Newton's law of viscosity, is known as non-Newtonian fluid, right? Whereas ideal plastic fluid in which the shear stress is more than the yield value, then after the shear stress is directly proportional to the rate of shear strain or velocity gradient is nothing but ideal plastic fluid. So these are the various types of fluids, right? I hope you understand. Next we'll move on to properties of fluid. We'll move on to properties of fluid, right? So at the very beginning of the session, I explained that the main why we have to study this particular subject, right? So why it is linked to our mechanical engineering, because we are going to, if you want to design any kind of devices like pumps and turbines. Mainly we have to concentrate on these fluid properties. What is the effect of these fluid properties, right? What is the behavior of these properties, right? Now we will see what are the different types of properties, right? So there are 8 properties are there mainly. Now we will see one by one. First one is density. Density of the fluid, or else it is also known as mass density, which is also known as mass density. Next one is specific weight. Specific weight of fluid or weight density. Specific weight or weight density. Third one is specific volume. Third one is specific volume. And fourth one is specific gravity. Fifth one is viscosity, right? So just now we have seen what is viscosity, right? Next one is compressibility, right? So we have discussed incompressible. Now here it is compressibility and bulk modulus. What is compressibility and what is bulk modulus, right? So this we will discuss deeply. And next one is surface tension. The last one is capillarity. Last one is capillarity, right? So these are the different types of properties of fluids which will plays a crucial or important role while designing any kind of mechanical devices which are related to the fluids like pumps or turbines, right? So these are mainly hydraulic machineries, right? So these are the main properties of fluids, right? Now we will see some quiz related to what we discussed so far, right? Now, what is fluid? What is fluid? A fluid is substance that A bit is it is always compressible, B bit always expands until it fills any container, and C1 is flows under the action of any shear force, and D1 is none of the above, right? So what we have discussed, fluid. Fluid is a substance that deforms continuously under the action of shear force, right? So correct answer is C. A fluid flows under the action of any shear force, right? Any shear force, right? Now next, consider the following statements, right? So what is the statement? First one is liquids are generally incompressible, right? So first statement is liquids are generally incompressible. Second statement is gases are generally compressible. Gases are generally compressible. And third statement is a fluid is said to be compressible if its density remains constant with respect to pressure of these statements, right? What is the correct answers, right? So we have discussed incompressible. Incompressible means the density will be almost remains constant. For what type of things the density will be remains constant? Means liquids, right? So for liquids generally the density of the liquids will be almost constant, right? So that means first bit is correct. Liquids are generally incompressible. Now move on to second bit, second statement. Gases are generally compressible. Of course, gases are generally compressible. We are using various gases, right? For example, if you take in IC engines, internal combustion engines, will mix a fuel as well as gas, nothing but air, right? So this will both get compressible, right? So that means gases are generally compressible, right? So statement 1 is correct and statement 2 is correct. Now the option is D, statement 1 and 2 are correct, right? Right. Why statement 3 is not correct? Because a fluid is said to be compressible if its density remain constant with respect to pressure of these statements. No. A fluid is said to be compressible if its density remains constant. Compressible in sense the density will be changes, right? So statement 3 is not correct, right? Now this will be the end of this session. So I hope you understand, right? So what we discussed mainly in this session, what is fluid? What exactly fluid is? Nothing but the substance which is capable of flowing is nothing but fluid. And we have studied what is fluid mechanics. Fluid mechanics nothing but branch of science which deals with the behavior of the fluids at rest and as well as in motion, right? The properties of fluids. We have seen different properties. Mainly we are concentrating on 8 properties. They are mainly density, which is also known as mass density, weight or specific weight, right? And third one is viscosity, and fourth one is compressibility and bulk modulus, fifth one is capillarity, sixth one is surface tension, and seventh one is specific volume, and eighth one is specific gravity, right? So these are the main properties of fluids, right? So in the next session we will discuss deeply what are these properties, right? So thank you for listening.